Okay, databases are awesome. There, I've just recapped the entire first 3 minutes of the class. All right, so what we are going to do today is we're going to look at a particular database called Postgres. Postgres is one of the more popular databases out there. MySQL, I think, edges it out in number of users, just because MySQL's been around for longer. Before I came here, I hadn't actually used Postgres. So I may make more typos than normal. I know that sounds crazy because my fingers are used to doing MySQL commands rather than Postgres commands, but it will all work out in the end. Okay, so first thing I'm going to do is I'm going to share my screen because I do that. Move that off there. Okay, and I was just trying to set my terminal so you can see it. All right. Hold on. Is this big enough? Can everybody read what's going on? Great.
Yeah,
that's right. Just want to make sure. Okay, so first thing I'm going to do is I'm going to show you this web page here. This is the Postgres site where you can come and download Postgres. You may already have it on your Vagrant machines. I believe you're also going to be using later something called SQLite, which is very similar to Postgres. Don't worry about the differences so much. So yeah, Postgres is cool. And Emil Skolnick, it's the first time I've seen that name. All right, seeing unexpected behavior. This is kind of a funny website. I hadn't noticed Uncle It down here. Right, so I'm going to be using my terminal pretty much exclusively today. So don't worry that you're not like, I'm not writing in VS Code and going to save it to a Git repo. Everything that I'm going to teach today, I've already got, I've written out and will share that document with you. So let's get started. Okay, let me go to, right, so relational data model. So I'm going to show you a database that I created. It's very, very small and tiny and not the best use of a massive database. Just has 2 tables. But the way we look at databases is we store information in tables. What other thing or application you can think of where people put information in tables?
Excel?
Yes, you got it. So let me just pull a random Excel spreadsheet. Nothing in here is real, by the way, so don't worry about it. This is how what you normally expect when you see an Excel spreadsheet. Now, all I'm doing is I'm storing data here. I'm not doing any analysis of the data. I'm not sorting the data. I'm not doing anything like that within Excel. Excel has those features, but I'm not using that. I was given this and was asked to make an application using this data. And because I was asked by somebody who wasn't a coder, they gave it to me in Excel because that's what they think of. So here we've got our data, and you can see we have at the top here, we've got our column names, and each of these represents, so in this case, a broker name. So all of these are brokers. So we have information here. We have rows, which is also known as a record. in database where we have all of the information. And you'll notice that there are some of these here that are blank. For many of these, they're blank columns. Matter of fact, some of these columns have zero information in them at all. I suspect that's because it will be populated later. But you can see that some of these are blank, and you can think of that as setting the data in that particular column to null, right? A column of data represents a single piece of information for each of these entries in this database, or, well, poor man's database. Okay, so I have what, 949 records if you don't count the title row. That's tiny. You're going to, in your career, I have no doubt you're going to be running into databases with millions or billions of entries in them. Databases can do things very, very quickly and very, very efficiently. So databases are not really great for introducing complex language or complex logic that you want to apply to the data. They're good at counting, they're good at storing information, they're good at pulling information, they're good at deleting information. The basic, and I'm going to refer back to the API talks we had earlier, basic CRUD operations. So create, read, update, and delete. This is what databases do. Databases also can do multiple changes or reads every second. Now, something that you've probably run across already is you have conflicts with data. So when I'm saying conflicts with data, say conflicts with Git. You may have a conflict, you're changing something, somebody else is changing something in the same row. So how do you deal with that when it comes to a database? Again, databases are really good at that. When you go to change a record, it will lock the data in that record. You can change the data, then it unlocks it, and then only then can someone else go in. So most of the time that's not a concern, but sometimes when you're dealing with hundreds or thousands of updates every second, you may have multiple entries that want to talk to the same piece of data. And so you have to have a way of dealing with that. Okay. So let me start off. I've already set up the database. Don't worry, I'll show you how I did that later. But let me just get into the database. So PSQL dash U, sorry, dash U, and my user here is Postgres. So dash U counts for the user. I have not set a password on my local Postgres database. It's fine for development and for local use. Please don't do that in a live database that is actually on the internet, because it will soon not be your database anymore. It'll be somebody else's. As an aside, security and databases are very, very important. Who here has had their information in one of these leaks? So Sony had dumped things. Hundreds of other companies have done this. I've been in multiple data leaks. Most of the information are things like my name and address, which for me, whatever, I don't care. But also, I'm not, say, an activist who is attempting to overthrow a regime or just have a difference of opinion with the powers that be. I'm in Canada. Everybody has a difference of opinion with the powers that be. That's why we're Canadian. We like it. Americans, a little more volatile, but yes. So the most secure data is the data that you don't store. So think about this down the road. Oftentimes you're going to hear, oh, well, we'll just store that data. We might need it someday. Again, if you don't have the data, you can't leak it. So if I don't have passwords that I can read, I can't leak the passwords, as I mentioned during the authentication lecture. So just think about that. Ultimately, you're not likely to be the person in charge of making decisions regarding data, but at least think about, hey, you know, what happens if my 3-person startup, somebody hacks our information and we just so happen to have, you know, Elon Musk is a user, and now we've leaked Elon Musk's password to the world. Yeah, that's not going to go well for you. Nor will it go well for Elon. All right, so I've run this PSQL command and I've logged in, -use for user. Postgres is the default user, I believe, for all Postgres databases. All right, and Postgres has a, I won't say strange, but a way that I was not familiar with before now of navigating. Hold on, let me just pull up my cheat sheet. Everything has a cheat sheet. Right, so everything in Postgres that isn't a direct SQL statement, and I'll show you a direct SQL statement later, is accessed via a backslash. And the most useful statement to learn first is the \?. And this gives you back all of your options when it comes to navigating or using the a Postgres database. And you can see here, your down arrow, there's a lot of them in here. I've never used 99% of these. And for the most part, you don't need most of these. It's like everything in coding. There's so much functionality that most people will never need. So first thing, I hit Q there, by the way, to get out of that. So that's actually kind of important. When you get into something and you see right at the bottom 2 colons with your the easiest way to get out of that right here is just hitting Q, because sometimes it's hard, it's not intuitive to figure that out. And we can also get out of Postgres by doing /Q. So /Q is quit. That should be easy. Now that we've done all that, let's actually get back in and do stuff. So the first thing I want to do is I want to look at all the databases. So I'm going to /L for list. You can see here that I have another user called John. That's amusing. So I have a bunch of tables here. One of them is called library, and that's the one I set up for today. So before I can do anything else, I need to connect to a particular database, right? Because otherwise it's not going to know. I may have tables with the same name in multiple databases, so you need to make sure you're connecting to the correct database. So I'm going to connect to library. Wonderful. So tells me exactly what's going on. I'm connected to the database library as user Postgres. And I guess the first thing you want to do whenever you're in a database is to look at the tables, because that's where the data is actually stored. So In Postgres, it's \DT. And you can see here that I have two tables. One's called authors and one's called books. So how do I actually look at the information in a table? Well, I actually have to send a command to the database itself. And this is actually how applications also request data from a database. They send what's called a query. A query, yes, is like a question, but you can also change data with the query. So whenever you see people using all caps like this, so I'm going to do select. I'm going to say select star from authors. All right. So here is my first tip. If you're anything like me, you're going to forget to use a semicolon. It is incredibly important in SQL to have to end your command with a semicolon. Otherwise, the database doesn't know that your command is finished. So maybe I want to do more than just select star from authors, star meaning everything. Maybe I want to filter it somehow. So it's going to wait for the next piece. So if I hit enter here, nothing's going to happen except the equals over here turns into a dash. And that just means there's a command ongoing. So if you accidentally hit enter and you didn't mean to go to the next line, you can just hit the semicolon and you get the information. I misspelled Tolkien's name. I'm so embarrassed. I just noticed that. Okay, so here I have a list of authors. There's no humor in my choice of authors. I know that's weird. You were expecting dad jokes. No dad jokes here. Some of my favorite authors, well, Shakespeare favorite might be a little bit of a stretch, but the rest of them are people that I like to read. I read Lord of the Rings when I was 10. It took me 6 months. Okay, so this is looking at the data. So there are very few rows and columns here, and it's easily legible. But maybe I have 1,000 columns. That's not uncommon in a database. And you can imagine how hard it would read if records were here. What happens if I do this? There we go. So pretend that that is a wider, so it's harder to read like this, right? So if I had thousands of records, it would jam up over multiple lines. So we can actually do something here, and that is set extended display. And what that does is it kind of inverts. So let me show you how that works now. So now it's showing each record with the columns next to it. So this will fit on pretty much any screen. So if you have to do database work on a phone, you can do it. I don't recommend it, but you can do it. I should also mention, because while I love the terminal and running things here, there are other tools available, Gui Tools. So here is Retool. I've not used this one, so I can't give you a recommendation. But this is a Gui tool for doing the same sorts of things as I've done or I've shown you. You may feel more comfortable using a Gui tool. However, I think it's important that every developer knows how to use the command line, even if you don't use it regularly, just because you may have to do something with your phone, in which case, as long as you have an SSH client on your phone or wherever, you can do work. You can actually access any machine or development machine and make changes. All right, I'm going to change this back to regular display. Okay. So this brings up what am I doing here? What are these queries? And these queries, you've got to actually think about the interface that I'm in as separate from the database itself. The database is just the data. It has an interface like an API for me to extract the data, which I'm using this command line tool to do. And this allows me to do two things. There are two parts to this. And hold on, what is it? Right, so there is the part of SQL that is a database, it's a data definition language. And then there's the data manipulation language. So, or DB, here, let me find the link that I created a little bit earlier so I can actually show you what I'm talking about. Right. So this is actually a really good Stack Overflow article here that talks about database definition language and database manipulation language and what the difference is. So part of the definition is how you define the data, whereas manipulation is how you get the data out of it. So part of what we do is define. Now, I'm not showing you define. I'm manipulating right now with a select statement. This link is in my notes that I will send you later. So we've got that. Going through my notes. So that is a select statement. So when you think about a database, I am not using HTTP here. I'm actually using a custom protocol in order to communicate with my database. And this protocol is actually the Postgres protocol. So you can think of a database as something that people generally don't need to look at. Most people wouldn't even know how, but applications will access the data in the database. Okay, S in SQL stands for structured. So we've got our data structure here. I've got my table. I can show you my books here. So I am just doing the uppercase for the SQL bits and the lowercase for names of tables and rows and such. So here we go. So I've got 4 authors and 4 books. Not really that much data, but it'll do. And I also have a relationship in my data. And you'll notice that each row in my authors table has an ID associated with it. Each row in my books also has an ID associated with it, but it also has something else, and that is the author ID. And this author ID is pointing at this table. So who wrote The Hobbit? Well, author ID 1. Who is author of ID 1? Well, it's J.R.R. Tolkien. I really got to fix the spelling of that or it's going to drive me nuts. Okay. So what I have here, this ID, is now all of these, yes, they are numbers 1, 2, 3, 4, but the important thing about this row is that it is called the primary key of this table. And that means how you identify a particular row in that data, you need to have a primary key. And other tables that want to reference this table need to use the primary key in order to get that information. This, the author ID, is called a foreign key. And a foreign key is something that exists in another table. So we have this relationship with the data. That's why we call them relational databases. So let's go back and look at our initial select. So we can select different data. Let's say I just want to have the names of all the authors. I don't care about the author color. I don't care about the number of books. I just want to have the names of the authors. And I can actually do that. Select. And the name of the column, author name. I must have a from, otherwise it's not going to know which table to get the information out of. So we're going to select the author name from authors. Note that the names of the tables are plural, which makes sense. We're storing more than one author. We're storing more than one book. Okay, so let's see what we get back here. And we get back 4 rows. You can see that this is actually a table. It's a table with 1 column in it. We have the column author name, and we have Tolkien, Shakespeare, Martin, and Doctorow. So this way we can get the particular information. We don't always need to get all of the information. Remember when we did an API call, we would always get all of the information from that API endpoint, even if we didn't need all of the information. Here we can specify what information we actually need and pull only that and then manipulate that within our program. I should also note that when you think about web development, there are normally 3 parts that you're thinking about. You're thinking about the front end, which we've been talking about last week recently. We have a back end and we have a database, and the database sits connected directly to the back end. You don't want to have the front end of your web app go directly to the database. You want to have your back end filter any information. There are good reasons for that. There is this databases, if people have direct access to them, can be quite easy to hack into. There is a here XKCD. So there is this really hilarious to a nerd developer, but hilarious nonetheless. And if you haven't seen XKCD, I'm sorry about all the hours you're about to lose. But here we've got a mom is talking to a school over the phone, and basically the school's asking, did you really name your son Bobby quote, close bracket, semicolon, drop table students. So what that actually would do if you sent it directly to a database. So if you sent something, so let's have a look. If I tried to add an entry into my authors table, so let me do this, insert into authors. And the way we do this is author name. This is also a query, by the way. And then we will type okay, and we'll put our good friend colon. Yeah, I'm not going to run this. So basically, I am telling my database that, oh, my line of data stops here. Remember, the semicolon always stops the data, and then it's going to start the next line. And drop table, well, you could probably guess what that does. Deletes the table and all the data within the table irrevocably. So you don't want to do that. So shows you the importance of making sure you're careful about the information that you're sending directly to your database. Back in the PHP days, this where people use PHP more and more often, this was more common because people would just send stuff directly to databases and not do what we call sanitizing. So this is not sanitized. So we would need to make a change to this in order to get the data into the right location. Let me put in a real, let me finish this without the joke so that we can see how we add information. So I'm inserting, author name is Bobby, color is blue, and num books is 10, sure, 10 looks familiar. And I have to finish it with a semicolon there. And I get this insert 01. It's, I can't remember what the 0 means. I believe that's the error code, which in this case is there's no error, so it's 0, and the number of records added. So now I can have a look at my authors table. So let's and you can see Bobby likes blue and has 10 books to his name. Okay, I'm going to take a short water break and ask if there are any questions so far.
John, I have a quick question.
Yeah.
Say you have a table with like 1 billion records,
yeah,
just as an example,
sure,
and you do an insertion like this,
yeah,
and you want to just see that it's gone into the table, but obviously you don't want to pull up the full billion records because it would take, you know, forever to render. Is there a way just to like test that it actually, okay.
So let me show you how to pull a particular record. See, thank you for the segue. That's a great segue. So I've got this table, and while there's only 5 in here, let's imagine there's 1 billion. Okay, so how do I get specific information? So let's say I've added Bobby and I want to see that Bobby got added. I can do something like, I can type select, I just want to see the entire record, star from authors. And what we want to look at is where. So where is our filtering clause? We're going to use where in order to specify. So how do we specify? Well, we can specify in a number of ways. We know that we just added a record. Actually, authors here should be lowercase. Sorry. And we'll say where author name is equal to Bobby. And this is going to return a single record. Now, let's say we don't know, there may be more than one Bobby in our table, but there's only ever going to be one collection where the name and the color and the number of books is correct. So because I can easily add here, let's add another Bobby. We'll say this Bobby has 30 because I've not put a constraint on my database. Have I put? Hold on, let me just make sure. Yep. All right, so I've added this. So I've given you my dirty secret. You don't actually have to put the commands in uppercase, but I'll try to remember to do that just so it's easier for you to determine which part of my line is which. So here I've got two Bobbies, one who likes blue, one who likes red. So I can easily do this search where author name equals Bobby, and you could probably guess what the next word is. And notice, by the way, that I'm using a single equals here. And equals is different in JavaScript and in SQL. SQL is a different language. So far, in order to web develop, you need to know JavaScript, you need to know CSS, you need to know HTML, and now we're teaching SQL. SQL is not, your browser can't read SQL directly, so this is why we need to go through a backend. Okay, so whoop.
John, when you're inserting, do you need to put the column names?
I believe I've always done it. Hold on. Let's find out. What's the worst that can happen? All right, so I believe you do, but let's see if we can add, we'll change this Bobby to a Robbie just so we can see. Let's have a look. No, you need to put in the, you need to insert the data that you're actually putting in. So you need to specify not just the values, but what the value relates to. So here,
I think in some of the, sorry to interrupt, I think in some of the SQL work I was doing in Compass, you didn't have to, but maybe it's just like specific to the Postgres or something.
Maybe this is the way I've always done it. I've never, it's one of those things I've never questioned. I've just done it this way and it's always worked. I believe you can change up the order of everything. So let's do this. So I'm going to put author name second. Or sorry, we'll say color, comma, author name. And there, that's inserted. Yep. So that works. I also believe you don't have, unless it's a required field, you don't have to add it. So in this case, I know that color is optional. So if I got rid of, with new names every time, get rid of red. And I believe this will work. Yeah, so that works because not all authors have a color associated with them. And once again, see, James has no color associated with it, just like William Shakespeare doesn't have a color associated with it. Okay. All right. So how did I create this database to begin with? So what I'm going to do is I'm going to delete all the tables from the database, and I'm going to recreate it all for you. So as I mentioned earlier, the command to delete a table and all its data is drop table. And so I'm going to do that. Now, it's important to do this in the right order. If I try and drop authors, see what happens. And you don't need to put the if exists in there, but often you will when you're doing what we call seeding a database. So I'm going to try and drop authors. And if I do, it says error, cannot drop table authors because other objects depend on it. And that's correct. The books are pointing at authors. If I remove the authors, then what the heck happens to the books? Right? So what's it pointing at? It's pointing at a table that doesn't exist. That could cause problems. So it's not going to let me delete that first. So I have to delete the books first. Okay. And I get back drop table, and now I can do authors. Okay, and does anybody remember how I look at all the names of all the tables? /DT. Did not find any relations. It calls everything a relation because it's a relational database. So you'll note that when I do have tables, it gives me back a table with all the tables in. If I go all the way back here, there we go. You can see that I've got this list of relations when I first requested the list of all the tables. And you'll see that this looks very much like the output given from a select statement. And that's because that's what's happening in the back. A select is being made against the database. And it's getting actual data back. All right, so I no longer have any tables, so let's create. Rather than force everybody to watch me type, I am going to cut and paste. So first thing I'm going to do is I'm going to pop in create table authors, and I'm going to open up a paren. Okay, I'm going to hit enter here. I could put it all in one line, but it's going to be easier to read if I put it in separate lines. So I'm going to create the table authors, and you'll notice now the equal has turned into an open paren, and that's to let us know that we are inside something. So we need to finish that and close it. So the first thing I'm going to do is create an ID. What I have to give the ID an actual type. So when we are creating our data, we have to add different types. In this case, I'm going to add the type of int for integer. I'm going to put in generated, And generated means that I don't have to add it. The database itself will add the ID, right? Because if I try not add an ID, I might try to add an ID that already exists. So let the table handle that, and I don't have to worry about it. And I have to put in always because it always needs it. And okay, so this is identity. There we go. And I'm going to put a comma. So this is the first row here. Sorry, column, first column here. Okay, next, I'm going to add in the author name. I hate using the word name all by itself in anything, just because I find it, in the past, I've had issues where people get confused. What actually is name? So when I can, I try and say, this is what name is in this case. So here, name is the name of the author. And that is a string. However, strings in SQL are called varchars. Why? Don't know. Just because. A different language. So, and you do have to specify how long your string might be. So this means if I try and create an author with more than 255 letters in it, that's going to cause problems. It's going to error out on me because, hey, you've only saved 255 characters for this author. So I've got the varchar here.
Do you want a comma between author name and varchar?
No, I don't. Thank you. It would have. I can type. All right, and I'm going to say not null. So this means that unlike the color, which I don't care if it's added or not, you must have the name of an author. Everybody must have a name, even Prince, or the artist formerly known as. I don't know how to type his name, but nonetheless. Okay, so we've done that, not null. So how do you think I add color? Somebody want to guess? What would the type of color be?
Just the same string?
Yep. I'm going to use varchar. And in this case, I'm going to set it to 20. Why 20? Sounds right. If you have a color with more than 20 characters in it, you're probably not a web developer. All right, I'm joking. You can give that number any number that you think will work. Remember too that you are not committed for the rest of the life of this database. If you want, you can go and change anything that you've added here. So I've added color, and I also had this number of books. So let's type num books. You know what? I'm going to change this to number of articles. And there's a good reason for that. And this is an integer, and it is also not null, because if you're an author, you have written something. That is the definition of an author. And finally, the last piece of information I am going to put in is, what is the primary key of this? And this one's easy. Primary key in this case is the ID. Okay, and one of these days I'm going to no, hold on. Yeah, let me do that one more time. Okay, primary key is ID. And I'm not going to put a comma after that because that's my last thing. And I'm going to put that there and finish that off. Great. No errors. I haven't made a mistake. All right. So let's have a look at it. There's no data in it, but let's do that again. All right, and I get back 0 rows. So it's giving me back all of the IDs, author names, colors, and number of articles for everything I've got in this table, which at this point is nothing. Okay.
Wait, you had to write create table again at the bottom?
No, it gave me back the name of the command. So
okay,
I didn't
sorry.
write that. That's what was sent back to me from Postgres. Okay, so let's put some data in here now. I'm gonna do this quickly. Yeah.
Sorry to interrupt. Just a quick question. So the last where you said primary key and then in parentheses ID, can you just explain that?
So this
is that just a reference point, or
it's telling the database which of the columns that I've created above. So in this case, ID is the primary key. A primary key must be unique. Everything else could be duplicated, but a primary key is always going to be unique, which is why I'm having it generated, because that way will be unique. I don't have to worry about it. The database will worry about it. Okay, so let me.
Sorry, just a question on that. So just to understand clearly, then everything has to have an ID, but ID is not a default primary key.
The ID is not, so I called it ID. I could have called it anything I wanted to. I'm calling it an ID because that's the convention to call the primary key of a particular record, or sorry, a particular table to be ID. You will see that other tables also have IDs associated with them. So let me, no, that's not what I wanted to do. What I wanted to do is this. I'm just going to add data and do it quickly. Oh, why can't you copy and paste, you fool? Copy. Come on, come on. I don't know what it's doing. There we go. Let's do this one more time. Perfect. Okay, so what am I doing? I am inserting, just like I did up here when I inserted Bobby. I'm inserting into authors, and I'm author name, color, and number of articles. And this is my default, and I fixed Tolkien's name, so that makes me feel a lot better. I can add more than one record at a time. And you'll also notice that none of these am I saying, oh, by the way, here's the ID, because I don't generate the ID. The table generates the ID. Okay. All right, so let's run this, and it should give me insert 04, and it does. Okay. I'm going to just quickly do the same for books. And I am going to stop at this point because you know everything up to here. So how do I add the foreign key? So I can add the foreign key. A foreign key is also known as a constraint. I'm constraining the database. So the way I add it, or sorry, not the database, the table. So I'm going to add a constraint. I need to give the constraint a name. So I'm going to say FK for foreign key. And again, I can call this whatever, but FK is kind of conventions because that's what I'm doing. And I'll hit enter here. I'm still in here, and I just say foreign key is going to be the ID, but it's not going to be the ID of this table, the books table. It's going to be the ID of the authors table. So next line, notice that there are no commas here. Okay. So let's look at what I've added. You'll notice that I have a column that I've added manually here called author_ID, which is going to be an integer. And I know it's an integer because that's what it is in the other table. In order to create the data for this table, I need to know what the IDs are from the previous table. I can't assume it's going to be 1, 2, 3, 4. It's going to be 1, 2, 3, 4 because there was no data in the database to begin with. They're going to be effectively they're random numbers. Okay, so I need to say we're setting a constraint. We're calling it the foreign key author. What type of constraint is it? It's a foreign key. Foreign key on the ID, and it's referencing author's ID. So let me close that off. There we go. Does describe work? I'm trying to remember. Oh, no, it doesn't like describe. That's a MySQL thing. But what I've done is I have added the foreign key, the author's key, so that it's going to point at that table. So I have a relationship between authors and books. An author can have multiple books associated with him. In theory, I can also have multiple authors associated with a book, but let's just do one way for now. So an author can have one or more books. Okay. And let me just add the data.
John, sorry to interrupt. I have another question.
Go for it.
Can you explain constraint? Like what is that doing exactly?
I am telling it that it's called a constraint because it is reliant on outside information. So it's reliant on information that lives in another table. I'm constraining the data in this table based on information in another table. So I need to I have to constrain because there's going to be an author for a book. Although I set it actually up here, that could be null. So we'll give that a go in a little bit when we add data. But the constraint here is that if there is an author ID, and notice that I have author_ID, and nowhere down here when I'm creating the constraint does it say author_ID. That is a convention. So we're going to the authors table where we are looking for a field called author, or sorry, we're called ID in the authors table. I can't call this ID here because ID is already set for this table. I've set it for the table itself, the books IDs, right?
Right. And so where you say constraint and then foreign key underscore author, that's just what you're naming it?
Yeah. Yeah.
Okay.
Again,
okay, cool.
I'm calling it that because it makes sense to me.
Yeah. Okay. Okay. Awesome.
Right?
Thank you.
Right. You're when you're coding, you're half coding for yourself and you're half coding for the person who needs to go and change this code 6 months from now, who might be you. And you're not going to remember what you did when you created this. Trust me, it will happen. All right, let's pop some data into this. I'm just going to, again, copy and paste. All right, and The Hobbit, Game of Thrones, Macbeth, and Fellowship of the Ring. Okay, super. Let's insert and this time I'm only going to send in a book name. Notice I use book name here because, again, name can be confusing. What am I naming? I'm naming the book here. All right, and nothing political about this statement whatsoever. So Harry Potter and the Author of Embarrassment. And oh, I always do this. Different databases like different things. I got to use single quotes. In JavaScript, it doesn't matter which type of quotes you use most of the time. In here, you absolutely must use single quotes or else you get an error. And key ID 5 is not present in table of authors. So looks like violates foreign key constraint. So there we go. And this is the constraint I was talking about, right? I must add something that exists in the other table. I must give a relationship. So I don't have the author of embarrassment in the other table. So I cannot add this record. It gives me an error when I try to add this record. And so I have to deal with this somehow. There must be a record. So in this case, I would probably require that that I add an author or the author exists. So search for an author, find it. If it exists, great, use the ID. If it doesn't exist, then create a new author. Okay. I love the engagement today. You guys are asking really good questions. Okay, speaking of really good questions, let's take a 13-minute break because my throat is really dry right now. Okay, so I will see everybody at 20 past the hour. Okay?
Hey, John.
Yeah.
Just the when you created the foreign key,
Yeah.
it says foreign key ID. Should it refer to the author? Should it refer to the key in the books table that?
So because it's foreign, we
Mhm.
are talking about another table. So we're saying that we're going to refer to an ID
Okay.
that references author's ID. And because I'm getting it from the author's table, it takes the name of the table, it depluralizes it. Is that a word? And then puts the underscore ID on it. So it knows which one I mean here.
Oh, okay. It kind of, yeah, it does that.
It's a little bit confusing, but yeah, it's one of those things you just have to deal with. Most of the time, you are scripting all of your additions into a database. You are not doing this manually the way I'm doing it right now.
Right, yeah.
Just
intuitively, I thought it would have said foreign key and then in brackets author ID, like because that's the key. But you're saying it automatically adds.
Yeah, it's actually referring to the ID in the actual author's table.
Oh, okay.
Right.
I thought, yeah, okay. Okay, thanks.
No worries.
I'd love to see your colony. Could you bring the laundry basket upstairs? So recently there was a band in space about people fell and they died. So we buried them. But 2 of them survived, and we tried to help as many as we can. And then this is the family and made that. Just making a copy of that. You were afraid you're gonna be sick. Oh no. Yeah, sorry. It'll pass. Hi, Boo.
Hey.
Well, did your class go today?
Hey, everybody. Databases are fun. Or at least I think so. But hey, I'm a nerd who's been doing this for far too long, so. Okay, super. Well, welcome back all. All right, let's, we want to deal more with getting information out of a database today. I've shown you how to create a database, and that's great. So you can work on it on your own. So that's not super important today, but there are a number of things that I do want to show you that are important here. So I've shown you how to filter searches using the where clause. Hold on. So let me get back into here, and then I have to do a /c for our library to connect to it. And then I can launch my request. So if I want to look at all of the authors who have a color of red, what is the command or the query that I need to put in? You can even start it and let other people finish it.
Select the color from authors or?
Okay, select color from authors.
So
Is
do
that
we
gonna
need
work?
an author's name or?
So if I want to add the author's name along with the color, how do I do that? Well, I can just put a comma here and say author name. All right, and I want to constrain this, and again, a word, but it's not the same thing. I want to find only the authors with the color of red. So how do I do that?
Where?
Where what?
Color is equal to red.
Color is equal, no, what am I putting here? Come on, Jane.
Yeah, equals.
Equals.
Yeah.
And I have to put red, and
Red.
red's a string. And then I have to finish off with a semicolon. Right, so it is going to give me the color and the author name from authors. Sorry, go ahead.
Sorry, does color have a U or no?
In Canada, it has a U.
In the table, though, you have it both ways, do you or not?
No, I believe I just have it with a U. And if I'm wrong, it'll give me an error, and we'll have a look. I often make errors, as you are aware. There we go. Color does not exist. Oh, see, I did need to put color. So there, red. So it's kind of interesting. Even though when I created it, the color came after the author's name, I can order these in any way I want. Okay, so let's do something else. Let's have a look at the authors, but I want to order them. So I want to have them in a particular order. Right now, they're just coming in the order that they've been created. But let's say I'm creating the New York Times bestseller list, and I want to see how many books each, or how many articles, I should say, each has written. So I can do that just by saying select, just do a select star this time, from authors. And here I could just, I want to have all the authors come back, so I don't need a where clause, but I can do an order. And it's order by, no, it's not order underscore by, it's order by, and I could say num underscore articles semicolon. And you could see that the number of articles, now it looks a little weird. And there's a reason for that. And that's because it's actually giving me the first digit, or is it? I believe it is. Well, I can reverse this just by saying, putting in a DESC. Where did I put that? I put it after, right? I knew that. So I am curious now. Let's insert somebody with 100 articles, just because I want to see. Insert into authors. We'll give it a give them an I'm not going to give them a color. I'm just going to give them a num. And I can't think of an author off the top of my head. So we'll, there we go. Thank you. My wife says Nathaniel Hawthorne. And I want to say 100. Okay, it worked. So let's run that previous and see what happens here. So it's interesting that, oh, actually, no, it makes sense. Ascending is from the smallest number to the biggest, descending is from the biggest to the smallest. The default is ascending. So you could put in ASC if you want, but you don't need to. You do need to do it the opposite way if you are doing it, or if you want to have it descending. So you must use DESC. So there we go. Nathaniel Hawthorne wrote 100 articles. Cool. All right. Okay, so we've got our two tables. But, and there's a relationship between the two tables, right? We have books, and these books belong to authors. We can have multiple books, and I do have 2 books associated with one author. So let's see how we actually get information. Let's say I want to have the name of an author plus all of the books that that author has written. So there is a key idea within databases and SQL called a join. We're going to join a query that queries 2 tables simultaneously. So how does this work? So I could say select, I'm just going to say star from and I have to say, give the relationship here. So this, there's a different syntax here. And what I need to do is I need to say authors dot ID is equal to the books dot author underscore ID. Okay, so this is a join. The default type of join is going to get everything where there are entries in both tables. Okay, so we have here not all of the authors. We have Tolkien, Martin, Shakespeare, and Tolkien again. We get Tolkien's color here, red, twice. We get the number of articles from him twice. We also get this ID. This ID is confusing because which ID do I mean here? In this case, it's going to be the book ID. And here we go. So we have J.R. Tolkien has The Hobbit, and George Martin has Game of Thrones, and Willie Shakespeare has Macbeth, and then Tolkien has Fellowship of the Ring. So let's do the same query, but we're going to put a group by author underscore, sorry, authors underscore authors dot.
Sorry, John, can I ask a question?
You may.
Okay, so the author books.author ID, is that the foreign key that you set up originally?
Yeah.
Is it or unless you set up another table, was it a FK underscore author?
Yes.
Was that the constraint?
That is the name of the constraint. It has no use other than when we're creating it, and when you're investigating databases later. Again, I'm doing an overview of databases, so I'm not going to get into all of the nitty-gritty details. Otherwise, we'll be here for the next 6 days because there's a lot to databases. So, all right, so I don't need all of this. So let's instead just get what I want. So I'm going to say authors dot author name, comma, books dot book name from authors, join books. So this is all of the books written by a particular author. We are setting what we want to associate. Yes, it's redundant because there's already foreign key setup, but we need to be specific here. So we're going to say the ID column in the authors table is equal to the author ID column in the books table. And now I want to group them by. In other words, I want to have all of the names that are associated, like all the names that are the same together. So here I had Tolkien at the number 1 and number 4 position. All right, and if I've got all this right, and of course, it didn't like that. So it doesn't like books for some reason. Oh, all right, let's get rid of the dot part here. No, it still doesn't like it. All right, I am going to look up what this query is supposed to be and let you know. But in the meantime, I'm just going to put a star here. No, hold on. There we go. Yes, I know there's a easier way to do that. Select star. What have I done? Column author's ID must appear in the group by clause or used in an aggregate function, the column authors.id. Oh, that's what's going on. I'm grouping by the ID because I need to. Always do your demos once ahead of time. All right, let's do star. Books ID must appear in, all right. That did not work, and I will fix that and put that in the document before I send it out. But there is a way where I can just grab the names of the authors, the names of the books, and is this the join? The join works up here. So it just doesn't like the group by. I've done the group by wrong. Yeah, we've just done the group by wrong. All right, we'll work on that, but you can group things. There are other types of joins, and what I've shown you is the simplest and most often used type of join, and that is called an inner join. And it's inner join, and you can think of it as I've got all of the authors who have books and the subset of that. So let me pull up this kind of cool, not that. I like this. Okay, this gives us information about the different types of join and when you're going to use them. When you do databases, you're going to see these circles an awful lot. So this is what we've just done, an inner join or just join, because again, that's the most often used. This is used 95% of the time at least. A left join will pull all of the records from the initial table and any matching records from the join table, as long as there exists a relationship. If there's no relationship, then it's not going to show them. So here we've got a list of users. Some of these users have likes. So let's have a look. So this is the join statement. So select users.name, comma, likes.like. Okay, this is one table, this is another table. On users.id equals likes.userid, and that's how we've done it. The left join basically puts the word left here, and you can think of left as being the left side of the set, right? So what's that called when you've got merging circles like that? It's escaping me for now, but there's a something you call these sets here. So
a Venn diagram.
Thank you, Venn. I was write that down, Venn diagram. Okay. We can also do a right join, which does what you would imagine. Again, it will return everything from the join table and anything from the initial table that also exists, that has a relationship with something in the join table. And finally, this is just going to return everything, whether or not there's a relationship between the two, which generally is not what you want. Generally, you want to do this. If you want to do an outer join, just pull both tables. That's fine. Okay, so I popped this link into the notes as well. So that's pretty cool. Okay, so we also have aggregation functions. And aggregation functions are a way for us to, hold on, there we go. Aggregation functions allow us to do things that databases are really good at. So they're good at things like counting. So if I want to count something, it will do that for me. So let me give you an example of count. Okay, so if I want to select the author ID, and now I'm using the keyword count, and I'm going to count the number of author IDs that I bring up. As not num books, hold on, I changed that. I changed it to num articles because I made the author's book without thinking about the books. Okay, so there we go. As, oh, actually, you know what? I can call this whatever I want. So number of books. No, this is right. I can call this num books, but I'm going to call it number of books. Okay, and I am going to select them from the books, and then I'm going to use here the group by will work. We're going to group by, we have to put in this group by, otherwise it's not going to work. Matter of fact, let me do it without first because books, so and put a semicolon there, and we'll just get rid of the rest of this. So this is going to not be happy. So I actually have to put in this group by clause. There's a lot of like weird things about SQL. SQL has been around longer than the web has. So everybody who wrote SQL is probably dead by now, so you don't have to worry about it. But they all did this in the 60s and 70s. And there we go. We have the author ID and the number of books they've written. And you can tell author number 1 is Tolkien, and we know Tolkien has written 2 books. So databases are really good at counting. So if you need to count a number of records that have been returned, or you need to count something within, doing them on the database actually makes more sense than pulling them into your front end app or your back end and doing the counting there. Databases can count very efficiently. So when possible, get the database to do that. All right. There is this idea called pagination. And if you want to display information on, say, 1,000 items, putting them all on one web page might not be the best user experience. So we want to paginate those. We want to give them in batches of a certain number. Now, my authors table is very short, but we can still do some basic pagination using select star from AU authors, and I can say limit. I'm going to limit it to 2 because there's only 4 in there. But you will see that this is only going to return the first 2 records. So if I want to display information on multiple pages, this is a great way to do it. And then when I want to get the next set, I just do a what's called offset. So offset 2, and I can also do, not that it matters, limit 2. I think that's going to work. There we go. So this now returns the second, the third, and the fourth author. I have to put the limit to here as well. Otherwise, admittedly, again, it's not, doesn't make a difference, but it would return the rest of the records. So you want to put in the limit is the number of records you want to have returned, and the offset is where are you starting from. So here I am skipping the first 2 with the offset 2, and I'm limiting myself to getting 2 records back. I can actually do the same thing with a limit of 1, and you should see that it's just George. Just George gets returned there. So offset and limit are kind of cool things. average. Let's do an average. Let's find out the average number of articles. So select and I'm just going to say author. Actually, let's do this. We're going to say select oh, wait, there we go. I know what I need to do. It's select AVG. AVG. There we go. AVG. So I'm going to select no. And here it is just taking all of the number of articles everybody's written, done the math for me. Wow, it really it gives me a really detailed number. But that makes sense. It's going to be a float because I did division. We can do min, we can do max. So let's do now here, it's just going to return to me the minimum number of articles, which might not be what I want. So I am going to also ask it to return to me the author. What did I do? Must appear. Oh, group by. It's one of these great things where it gives you the information. Yeah, I see what's going on here. So that's weird. All right, I'll figure that one out as well. For some reason, Nathaniel with his 100 is above Tolkien with his 10, but that makes me think that it's not doing math super well. So I'll figure that out. Why that's working the way it is as well. And I've shown you the limit, I've shown you offset. Pagination is important. All right. So I'm going to give you a couple of challenges. Let's say, and just to make it easy, I'm going to select from authors, just so you could see all the data in front of you, and select star from books. Okay, so these are the two tables. What statement would I add if I want to list the authors who have written more than 10 books and have the color of red? How do I start that out?
Select.
That's pretty safe.
Star.
Yeah.
From. Authors. Where. Was it color equals red, John?
Yeah. So we'll say and I have to put red in quotes. And I also only want those with more than 10 books.
And num articles greater than 10.
Let's have a look. Woot! So even though Tolkien and Doctorow both have red, Doctorow is the only one who's written more articles, or the more than 10 articles, I should say. All right. Oh, here's something cool. Let's say, so we have colors. Now here you can see I've only got two colors. I've got red and I've got blue. So let's say I want to see what are all the colors that I've got listed. Obviously, I don't want to see red twice. I just want to see red once. So I can do a select distinct. And it helps if I don't typo. And there we go. So it's also given me a blank row. That actually makes sense because there is an entry null associated with those without colors. So the value of a color for something that I've not added as a color is going to be null. Oh, here's my earlier. So let's do this one. This is one I was having trouble with earlier. So select author name, and then I'm going to count the number of books as book count. So this is, I'm renaming this count books ID. I have to give it a name so it can create a column to put that name, that data in. And I'm pulling the author name from the books, but I need to join because I need to get the author's name. That makes sense? Right? So William Shakespeare, this is the one I tried to do up here. So William Shakespeare has one book, George Martin has one book, Tolkien has two books. And I got those names from the authors just by doing this join. Join authors on authors ID equals authors underscore ID. And I have to do this group by author name. Okay. So I have a number of, in my longest set of notes ever, 300 lines of notes here. I've got a number of like different things that you can have a look at and run on your own. Before the hour is up, I wanted to ask if there were any more questions. No? All right, everybody's a database expert, great. So later on, I believe Warren, I think I noticed today that Zola is no longer associated or with us. So it looks like Warren will be going over more information about databases later this week. But other than that, I think I've shown you everything I want to show you. Look at the notes that I post. It's going to be in a GitHub repo, so you can pull that repo and have a look. I also have the queries that I use to create the tables. Those are also in there, and you can, if you have a SQL database set up on your own machine, you can insert the data and play with it yourself. All right.
How about this question?
I like questions.
Where is the database? Where's the file that the database is stored in?
That is a very good question. And the answer is I don't know. It is on my machine. You cannot go and directly edit that file, however. You might be able to in SQLite, which I believe, again, you're going to be working with later. But real databases like this are, they're in binary format. And just because it's easier for them to manipulate the data that way. And so I could find out where the files are, but I think it's probably here. Let's have a look. /q, sorry, it's going to be here. /q cd /etc here. I installed it with Brew. Mac Postgres DB. There we go. You're not the first person to ask that question. And show data directory. Okay. If you can connect to the database with super user access, which I have, let's find out. There, that's where it is on my machine. It might be different than yours depending on how you've set it up. Let's go into that folder and have a look. All right. And there are a bunch of folders here. Let's open up in VS Code because it's the best way to look at a bunch of files at the same time. Yeah, okay, sure, why not? I'll trust them this time. And you can see there's a lot of different files or folders and files in here. They're all going to be in a format that I can't look at them in, or at least I can't look at them with VS Code. But in general, that doesn't matter. You're going to always interact with your database via a command line or a GUI client. Databases can get huge as well. So if you're planning on, years ago, I did an assignment where I had to pull in, it was a 12 gig database. And it took me a while because it was, I wasn't on broadband at the time, and manipulating the data on 12 gig database was fun.
We also communicate with the database from our server, right? Eventually.
Yeah, so there will be, just to cut to the chase, there is going to be a third-party library. So we'll probably be doing it with Node, third-party library that connects with Postgres. You just add in the username and password for the Postgres user that you want to use, and then you can actually send direct SQL statements to the SQL server and it will return the data. It's not going to return the data exactly the way that you see it here. It's going to return it in a format that you can use inside your program. And I'm sure that that's coming up shortly.
Thank you.
No worries. Thank you. All right, my friends. I enjoyed that. That was the most prep, by the way, I've ever had to spend on a lesson. So
is my SQL really different?
The statements are the same. So select star from is still the same. The commands like backslash are all different. You don't use those in MySQL. You use regular commands like quit and such. So Postgres is fairly popular because it deals with JSON data, which is important these days wasn't necessarily as important, say 20 years ago when JSON didn't exist. But MySQL has been around for a long time. Postgres deals with JSON data in a better manner. So you're going to see a lot of people using Postgres. However, MySQL is still more popular as far as I remember. All right, you guys rock. Thank you so much, everyone. If you do come up with questions after the class, post them into the channel or send them to me, and I'll be happy to respond and answer anything for you. All right.
Thanks, John.
Thank you.
Thanks,
You're the best.
John.
Thanks.
Best students
very much.
ever.
Thank you.
Thank you.
You're welcome.